Okay, so for the second question, I went through the explanation. So there's this huge explanation about average force of a rocket equals the mass times the average acceleration, blah blah blah. So this tells me that we're gonna have to use the F equals ma, Newton's second law. And then it also goes on to say change in velocity equals the average force times the time divided by the mass. So it looks like we're going to do a little bit of manipulation of equations. So let's start with Newton's second law is force times mass times acceleration. Um, the question, when I went to it, is actually asking for the change in velocity, which is delta V. So basically, what is going on here is the equation can be manipulated to find delta V. So F equals ma is Newton's second law. Now, acceleration, and we can manipulate this equation to find acceleration is equal to F over m, right? But acceleration also equals the delta t over delta v, or I'm sorry, what am I talking about? Delta v over delta t. So the change in velocity over the change in time. So if we want to find our delta v, we can just manipulate this equation here. Delta v is equal to a times delta t. And then we can just insert this, what we derived from Newton's second law, into here. So we have delta v equals F over m times delta t. So we have all of our values from the actual problem. F is equal to 20, I think kilonewtons, and was it 20? Let me see. I think it was 20. Yep, 20 kilonewtons, and what else did they give us? Oh, it says that time equals 8 seconds. This is kind of crooked. And then it also gave us a mass of the rocket of 1,000 kilograms. So we'll just put this into the equation. Delta V equals the force 20 times 10 to the third, because it's in kilonewtons, so we want to multiply it by 10 to the third to get newtons, times 8 seconds divided by 1,000 kilograms, and equals 160 meters per second.